So in this example, we have a rocket that's launched vertically, reaches a velocity of 630 meters per second up. Now that is not our VI. That's not the initial velocity when the rocket leaves the ground. It's its velocity once it gets up in the air. So this is our VF. And before I go and deal with the rest of the question, I'm going to loop back a second. The rocket is launched from rest. This is going to be a key thing that comes into a lot of situations. That rest is the initial situation, and we put that instead of putting the actual numerical velocity for one reason. That would mean that VI, when it's launched, would be 0 meters per second. And the reason we don't put the number 0 is because it actually has no sig figs to it. We would not be able to do the question. So one, it allows you to read a little bit more and interpret the question. And two, it also fixes a sig fig issue. Going back into what we know, it gets to an altitude of 4.7 kilometers. That is its displacement. And obviously that is up. Now before we move on, we cannot deal with kilometers in a calculation. We need standard scientific units of meters. So we multiply that by 1,000, meaning this is 4,700 meters up. And determine the rocket's acceleration. That is A. Again, looking at the list of formulas to see what fits, there is one equation, that is VF squared equals VI squared plus 2A delta D. Substituting in VF is 630, that will be squared. VI 0, which is squared, plus 2. A we don't know, delta D 4,700. Doing the math, 630 squared is 396,900. 0 squared is 0, and with the second term we can multiply the 2 and the 4,700, so that side will work out to 9,400A. Solving for A, divide both sides by 9,400. Going to 2 sig figs, as that's what we were given in the question, we get that A is 42. Acceleration measured in meters per second squared. And as it is a vector, our final velocity was up, our displacement was up, our acceleration is also up.